I'm going to go over a few homework problems from chapter 6.3, trigonometric functions of any angle. So starting with number 2, it says for an angle of the following measure, state which quadrant the terminal side lies. So we're looking at negative 466.5. If we want to find an angle that is coterminal, we can just add 360 degrees. So we have negative 466.5 plus 360, which is negative 106.5. So to find that angle, we're going to start with here, and we're going to go, here's 90, here's a negative 90. And so we're just going to go a little past negative 90. And so here is our reference triangle, which is in quadrant 3. The next problem I want to look at is number 3. It says, for the following angle measure, state what quadrant the terminal side lies in. So it says 421. So we have a full 360. So we need to take 421, subtract 360 to find out what's left. And that's 61 degrees. And there's our reference triangle. So the terminal side lies in quadrant 1. The next number I want to look at is number 6. Find the complementary and supplementary angles. So we have 22 degrees, 49 minutes, 45 seconds. To find an angle that's complementary, we need to subtract from 90 degrees, which is 89 degrees, 59 minutes, 60 seconds. Subtract, and we have 15 minutes. I'm sorry, 15 seconds, 10 minutes, and 67 degrees. And then to find an angle that is complementary, or I'm sorry, supplementary, we have to subtract it from 180 degrees. So 180 degrees is 179 degrees, 59 minutes, 60 seconds. Subtract, and we have 15 seconds, 10 minutes, and 157 degrees. So it's 157 degrees, 10 minutes, 15 seconds. Okay, so that was number 6. I'm going to skip over to question number 8. It says find the 6 trigonometric function values for the angle alpha shown. So we have a sketch in the first quadrant, and the point is 24,7. So that is our x and our y. So if y is 7, x is 24, now we need to find r. So using the Pythagorean theorem, that's r is equal to the square root of 7 squared plus 24 squared. And that's 25. And now we can find the value of the 6 trigonometric functions. So the sine of alpha is y over r, which is 7 over 25. The cosine is x over r, which is equal to 24 over 25. The tangent of alpha is equal to y over x, which is 7 over 24. And then we can find our reciprocal functions. Excuse me. So we have the cosecant alpha is 25 over 7. The secant alpha is 25 over 24. And then the cotan alpha is 24 over 7. Number 10. The terminal side of the angle theta in standard position lies on the given line in the given quadrant. Find the sine, cosine, and tangent of theta. So let's go ahead and sketch this out a little bit. It says it's in quadrant 2. So this is the line 2x plus 3y equals 10. So what we need, though, is to find a point on the line. So what you could do is to make it even integers. You can, let's see. Oh, that's a 0, right? So 2x plus 3y equals 0. We can make x a multiple of 3, y a multiple of x. So if we let x be a -2, so 2 times -2 plus what we could do is let x equal -3 and y equal +2. So that would cancel things out. That would be -6 plus 6 is 0. So that works. So I'm going to put those 2 points, -3, 2. So if x is -3, I'll put that here. Y is 2. To find r, we take the square root of -3 squared plus 2 squared, which is the square root of 9 plus 4, which is the square root of 13. So to find the 6 trigonometric functions, the sine of, let's see, this is theta here. So the sine is y over r, which is, and here's my x and here's my y. So y is 2 over square root of 13. The cosine, okay, now it says type an exact answer using radicals as needed and rationalize all denominators. So we will definitely need to rationalize this. So we have 2 square roots of 13 over 13 for the sine. And the cosine is equal to x over r, which is -3 over square root of 13, which is -3 square root of 13 over 13. So there's my cosine. And then the tangent is y over x, which is 2 over -3. And there's our tangent. And this is number 11. A function value and a quadrant are given. Find the other 5 function values. Give exact answers. So it says the sine of theta equals 1/6, and we are in quadrant 2. And we know that is y over r. Okay, so we're in quadrant 2. So we know r is 6, y is 1. To find x, we have to do 6 squared minus 1 squared and take the root, which is 36 minus 1, or 35 under the root. So x is negative square root of 35 because we are in quadrant 2 where x is negative. So our point on the terminal side corresponds to negative square root of 35, comma 1. Let's see, we have sine, so the cosine is x over r, which is negative square root of 35 over 6. And the tangent is y over x, which is 1 over negative square root of 35. Rationalizing the denominator, we get negative square root of 35 over 35. And then we need the reciprocal functions. So the cosecant, get another color here. Okay, so the cosecant is equal to 6 because we're looking at the reciprocal of sine. The sine, I'm sorry, the secant of theta is reciprocal of cosine, which is negative 6 over square root of 35, or negative 6 squared is 35 over 35. And then let's see, the cotangent of theta is equal to negative square root of 35 over 1, which is just negative square root of 35. Skip over, let's see. Well, we could try number 12. Find the reference angle and the exact function value if they exist. Okay, so we're going to first find out what quadrant we're in with 150 degrees. So this is 0, there's 90, there's 180. So I know I'm going to stop here in quadrant 2. 180 minus 150 is 30 degrees. So now we have our reference triangle. And it's a 30, 60, 90. So the ratio of the sides are 1 square root of 3, 2. The x is negative. So we have negative square root of 3, comma 1 for a point on the terminal side. And so what is the reference angle? That would be 30 degrees. And then we are asked to find cosine of 150. So the cosine of 150 degrees is x over r, which is negative square root of 3 all over 2. Gonna skip over to number 15. It says find the reference angle and the exact function value if they exist. So let's see what quadrant that's going to be in. So if this is not 0 degrees, and we're going the negative direction, so this is negative 90, negative 180, this is negative 270. So we're going to stop in quadrant 2. And so 240 is 30 away from 270. And so this, it has to be a 60-degree angle here. And so across from the 60 is the square root of 3. Then this must be 30 degrees up here, and that's a 1. So it's a 1 square root of 3, 2 triangle. So the cosecant of negative 240, the cosecant is the hypotenuse over opposite, because it's the reciprocal of sine, or we could say r over y in this case. So r is 2 and y is the square root of 3, which is equal to 2 squared roots 3 over 3 after rationalizing the denominator. Okay, that was number 15. I'm going to jump over to number 17. Okay, so find the sines of the 6 trig functions for the angle 305 degrees. So we just need to do a little sketch. 305 is almost a complete rotation. So this is 305 degrees. So if this is 360, then 360 minus 305 would be 55 degrees. So this is our reference, reference triangle. So the sine, okay, let's look at the x's. So the x's is positive, but the y is negative. So we have the x is positive, the y is negative. And of course, the hypotenuse is always going to be positive. So the sine of 305 degrees is x over r, which is a positive over a positive. So the sine is positive. The cosine is y over r, which is a negative over a positive, or negative. And then the tangent is y over x, which is negative over positive, which is going to be a negative number. And then for the reciprocal functions, the cosecant will be positive, secant will be negative, and cotan will be negative. They'll just take on the same value as their reciprocal functions. I think I have one more left to do. The last problem is navigation. So it says an airplane flies 100 kilometers from an airport in a direction of 230. Do I want to do this one? Hold on, let me see if we have another one. Oh, here's another one. Yeah, here's another one where we can actually sketch it out ourselves. Okay. I don't mind. All right, let's do number 20. Let's do number 21, because I'm looking at the sketch and I don't know if it's really clear to you, so I'm gonna go ahead and do that. Okay, so now we always do navigation starting with the north. And it says an airplane flies 100 kilometers from an airport in a direction of 230 degrees. Okay, so we have 90, 180, 230. Draw the reference triangle. Since this is 270 and this rotation is 230, 270 minus 230, that gives us 40 degrees here. Let's see, how far west is the airport? How far west of the airport is the airplane and how far south? Okay. So the airplane flew, here's the airplane. It flew 100 kilometers. So that's my R. We don't know what Y and we don't know what X is. Okay, so to find out how far west, we need to find X. And if this is east, this is west, this is south, okay? And to find how far south the airport is, we need to find out what is Y. So we could do the sine of 40 degrees is equal to Y over 100. And so we can solve for Y is equal to 100 times the sine of 40. So we have 64.2, which is about 64 kilometers. So that is how far south the airplane is from the airport. Then to find out how far west it is, we're going to do the cosine of 40 because that's the adjacent x over hypotenuse r, which is 100 kilometers. So x is 100 times the cosine of 40 degrees. So 100 times cosine of 40, and we get 77 kilometers. Okay. So in, let's see, in number 22, it's saying you're going to have to sketch this one out. An airplane travels 120 kilometers per hour for 2 hours. So 120 times 2, so the airplane actually went 240 kilometers in a direction of 200 degrees. Okay, so from the north, going in clockwise from the north, so we're going 200, so 90, 180, there's 200. Draw a reference angle or triangle. And if this is 270, we know that this is going to be 70 degrees in there. And the plane went 240 kilometers. We need to know how far south of the airport is the plane. So we want to know what is Y. So that's across from the angle. So that's the opposite side. So we know this is the sine of 70 degrees is equal to Y over R, which is 240. So Y is 240 times the sine of 70. And we get 226 kilometers. And that's it for the homework. So I think you all should be in pretty good shape. Have a good day.